Volcanic eruptions, earthquakes, forest fires. When natural disasters put human lives at stake, every second counts. Artificial intelligence, drones and robots can buy valuable time in rescue operations. How technology can help mitigate natural disasters, that's our topic on Shift. Natural disasters cause enormous damage worldwide and claim countless lives. But protecting ourselves from them can be tricky. Even today, it's difficult to accurately predict volcanic eruptions and earthquakes. Fortunately for us, some animal species have finely tuned sensors and will even exhibit certain behaviors before catastrophes. We visited the scientists investigating how animals can be used as early warning systems.
We
believe the Internet of Animals has the potential to become an early warning system in the future.
Many animals have better senses than humans. Some species can smell better, others can hear better, and some can even sense danger before it shows its face. It's been documented that before natural disasters, herd animals become agitated or change their behavior.
Zum Beispiel in Banda Aceh.
In Banda Aceh, for example, and many other parts of the world, it's said that animals ran away from big tsunamis or essentially warned of earthquakes. It's hard to confirm, but we're seeing more and more evidence that something like that's at play.
In some cases, animals started behaving differently many hours prior to a natural disaster. Behavioral biologist Martin Wikelski and his team are exploring the so-called sixth sense. As part of the Icarus project, the scientists equip animals with transmitters.
We're now able to observe animals around the clock, wherever they are. This means that for the first time, we can receive continuous information about them, which is then fed into the Internet of Animals. It works by giving them little electronic devices. We call them wearables for wildlife.
The wearable sensors send information in real time via cell phone network or satellite and can even exchange it directly, effectively from animal to animal. The data is then analyzed using artificial intelligence.
Take an ear tag on a rhinoceros. The beauty is that the ear tag doesn't just record data, like the speed or whereabouts of the animal, but it also interprets the data. That is, we have artificial intelligence in the ear tag that we trained beforehand. All of that allows the animals to effectively communicate with us.
In recent times, however, the project has been under enormous strain. The signals for the Icarus project were transmitted in part via the International Space Station in collaboration with Russian partners. After Russia's invasion into Ukraine last year, the cooperation stopped. But there's something new in the pipeline.
We'll launch a new satellite next year, and then have a much better system which we control ourselves. In 10 years, I believe we won't just be consulting the weather forecast, but the animal forecast, a report from life on Earth itself.
Animals as early warning systems, it's an intriguing approach. And really, anything that can reduce damage or support rescue teams is worth exploring. After the earthquakes in Turkey and Syria, aid workers and sniffer dogs were first on the scene. High-tech equipment didn't play as big of a role. Why? Well, experts say two things are needed: well-trained personnel on the ground to operate the equipment and more companies producing such tech in the first place. Several companies from Israel banded together for a rescue mission in Turkey. They sent experts and high-tech equipment to assist search teams. The startup Extent, for example, makes inspection drones, which fly into buildings through small openings. The crew even managed to rescue a woman a few days after the quake. Tech like this is gaining traction. Check it out.
This drone can deploy small robots directly on the scene of an accident. The European-Japanese Cursor project integrates various devices in a network. The aim is to make rescue missions run as smoothly as possible. The soft miniaturized underground robotic finder, or SMURF, is seen here in action.
The SMURF is this kind of robot here that is equipped with different cameras, like RGB cameras, 2 pieces. We have thermal cameras, and we also have lights on so that we can take this robot into a collapsed building and search for victims.
Nowadays, there are even sensors that can detect survivors based on smell. In the future, teams of these semi-autonomous robots could go deep into collapsed buildings and search for people. Drones up above can offer support to rescue teams down on the ground. Some are equipped with 3D mapping technology. Others use radar sensors to locate survivors under rubble and airdrop Smurfs exactly where they're needed. Another type of drone can establish an autonomous radio network. This allows data to be transmitted, even when communication infrastructure is destroyed or overloaded. The system is designed with both disaster victims and response workers in mind.
The new technology, we are aiming to increase the safety of first responders, providing remote access to the work site, remote working conditions, and secondly, with the technology, we are improving the speed of detecting victims.
It may be years, though, before this network of robots and drones is fully operational. This rescue robot from China is also still in development. It's quite nimble and can even climb stairs. In the future, its sensors could provide information about the scene of an accident and identify potential hazards like gas leaks. To do this, it's equipped with a laser scanner, thermal camera, and a gas sensor. This snake-like robot from Japan can navigate through rubble, wriggle through pipes, and even climb ladders, thanks to its 36 flexible joints.
First of all, these robots are used to enter places that are inaccessible to humans or places where there's uncertainty if it's safe to enter. Robots can help to measure oxygen concentration or CO2 levels, for example. Then you can evaluate whether you can send in a rescue team.
With its agile and flexible frame, the snake robot doesn't get stuck as easily as other robots. The bot's movements are guided via a controller, and the bot's equipped with a camera and sensors. Like other rescue robots, its future aim is to minimize risks for rescue workers and aid them in finding survivors when the clock is ticking.
These robots perform well in controlled settings, but conditions in disaster areas are unpredictable. Imagine what would happen if the internet and power supply collapse. It might be some time before robot dogs can compete with the real deal, says Professor Carsten Berns. He is an expert on rescue robots.
You would need several robotic dogs working in tandem to comb through a disaster site. Otherwise, time would quickly run out. Systems today are still very, very slow. That's a drawback of robotic dogs, especially when compared to an actual dog that could run across a field of debris relatively quickly. And we're still a long way from replacing a search dog's nose and sense of smell with sensor technology, for example. In that way, nature is a tough act to follow, and we won't be on that level anytime soon. But on the other hand, we've developed other sensors that don't occur in nature at all.
So the advantage is that robotic dogs can be equipped with essentially any sensor imaginable and transmit data in real time. Of course, it would be better to prevent buildings from collapsing at all. Luckily, digital technology can help in that regard too.
These rooftop devices balance out vibrations. The tech is developed by the Italian startup Isaac. Heavy sliding weights are controlled by algorithms. During an earthquake, sensors on the walls provide data on the building's vibrations. An external control system calculates how much the sliding weight on the roof must move to counteract the vibrations, thereby minimizing damage to the building.
Unlike earthquakes, which can cause major damage in the blink of an eye, forest fires develop more slowly. But a small smoldering fire can grow into something uncontrollable. Here, timing is key. Special sensors and AI are becoming crucial.
When it comes to battling forest fires, every second counts. But fires are not always discovered and reported right away. With the right technology, that time lag can be fixed. A number of companies have begun using artificial intelligence that analyzes satellite images and sensors on the ground, checking for smoke or shifts in thermal infrared data that could indicate a fire. And if one is detected, first responders receive a notification.
With machine learning, we can actually teach the computers to identify an actual flame, or we can also teach that technology to determine, if it's using thermal imagery, whether it's a stationary flame from perhaps a power station compared to a moving flame from a wildfire. So in that sense, the technology for automated detection is really important.
The first stages of a forest fire aren't always easy to spot. Sensors like these can help. In the case of a smoldering fire, smoke can remain trapped under the forest canopy undetectable by satellite. But gases are measurable, and German startup Dryad has developed a system which detects gas buildup in the early stages of a fire. The integrated AI can even distinguish fire gases from car exhaust, for example. Fire departments are then informed via an independent radio network and can quickly find the source of the fire using GPS before it spreads. Wildfires are hard to control. Depending on the wind, a fire's course can suddenly change direction or spread much faster. Smart fire maps predict how a fire will act over the next hours. They use deep learning software and factor in the weather, dryness of vegetation, past fires, satellite and ground sensor data. There's also software that simulates the spread of wildfires to help firefighters decide where to concentrate their efforts and plan evacuations.
As data gets more precise, technology will undoubtedly serve a bigger role in managing disasters. People's lives, homes, and the environment depend on it. High-tech solutions can help rescue workers who put their health and lives on the line. I hope that robots and drones will soon take over the most dangerous aspects of these jobs, even when it's not strictly profitable for companies. What do you think? Should taxpayer money fund the development and production of rescue tech? Tell us what you think. Bye-bye.